Ready? All right. Good evening, everyone. Welcome to Adirondack Water Week, Thursday evening edition. This is our fifth out of six talks in our series. My name is Dan Kelting. I am the Executive Director of the Paul Smith College Adirondack Watershed Institute. With me tonight is Zoe Smith, who's the Deputy Director of the Institute, and also our guest speaker for the evening, Brendan Wiltse. I'll say more about Brendan as part of my introductory remarks for his particular talk. But just on this title slide, I just want to acknowledge our partner in this effort. So it's a partnership between Paul Smith College Adirondack Watershed Institute and Northwood Schools. So there were quite a few folks on our presentation series tonight, particularly from Northwood. So we're excited to see that participation tonight. So we are in the fifth talk in the series, as I said a moment ago, and we've had four other talks. We've really been focusing on modern threats to and concerns to our waters here in the Adirondacks. I kicked it off with the history to kind of set the stage. Tomorrow night is our concluding session. Zoe will be leading a discussion on community action to protect clean water. So it's meant to be, so we all hear about these threats, and we're going to talk about opportunities and tools, actions people can take to protect or restore the waters that we care about so much here in the Adirondacks. I'm going to turn it over to Zoe for a moment. I'm going to go through the process for Q&A.
Great. Well, thanks again, Brendan, and thanks everyone for joining us. We are at 100 participants, which is breaking a record for Water Week. This is great. And we're really happy that the Northwood folks could join us, and there's a lot of repeat customers. This is wonderful. So tonight's presentation will be around 40 minutes, and then we'll have some time for Q&A. But you're welcome to send your question at any point. And in order to do that, you find a Q&A icon at the bottom of your screen. If you just press that icon, a window will pop up and you can ask your question. If you're more familiar with the chat function, you're welcome to find that icon at the bottom and type a question into chat. And Dan and I will monitor those questions and present those to Brendan at the end of his talk. So if you're on an iPad, it's possible your icons might be at the top of your screen, but if you're on a computer, then you'll see them at the bottom. And we're at 113 people, Brendan, just so you know. So awesome. Thanks again, everyone, for joining us, and I'll sign off right now.
Thank you, Zoe. Brendan, you can go ahead and I'll take mine down and you can share yours. So I just want to remind everybody that all of the presentations that have been given thus far, and then Brendan's tonight and also Zoe's tomorrow night, will be available as recorded webinars through the Adirondack Watershed Institute website, adkwatershed.org. You should have received an email from me maybe an hour ago with the updated link. And so I'll send that out again tomorrow once this presentation is trimmed and processed and ready to be viewed. So they're all available for folks to look at. So with that, it's really my pleasure to introduce Brendan Wiltse, who I'm thrilled to say is the newest employee of the Adirondack Watershed Institute. Brendan is directing our water quality program. He's the director of that program. He has a split appointment with the college, teaching within our new Masters of Science and Natural Resources program, Natural Resource Conservation program, rather, at Paul Smith. Brendan's actually alumni at Paul Smith, which is really great. He also has a PhD from Queen's University. Brendan comes to us, many of you know him from his previous position as the Science and Outreach Coordinator for the Ausable River Association. And one of his big initiatives at the association, which will continue on here with AWI, is the work that he's done on Mirror Lake with respect to road salt. So that's going to be the topic of his presentation this evening. Brendan is a broadly trained limnologist, and I would say also ecologist and a naturalist, has a lot of interests. he's an amazing photographer. This is one of his images. I'll let him talk to you about it. But he, you know, is a paleolimnologist, so he looks at lake sediments to reconstruct climate history and other histories of lakes, which is really fascinating. And he's been recently doing a lot of work with environmental DNA, specifically to map the distribution of brook trout within the Ausable River watershed. So we're thrilled to have Brendan talk to us tonight about road salt pollution in the Mirror Lake watershed. Take it away, Brendan.
Great, thanks, Dan, and thanks to everyone for tuning in tonight. It's exciting to see so many folks on the webinar and from all over the world. I guess one of the positives of our new normal, right, is that we can all get together from all over the place to share stories and information like this. So I'm going to dive right into it. So today I'm going to be talking about road salt pollution in the Mirror Lake watershed, and I'm going to start by giving a bit of a broader overview of the issue of road salt in general, and then we'll narrow our focus into Mirror Lake. So when we use the term road salt, that's a sort of a generic term for a lot of different things that can be applied to our roads, sidewalks, and parking lots in the wintertime to help maintain them free of snow and ice. The main chemical that we refer to, though, in most cases is sodium chloride, so NaCl. But there's also other chloride-based de-icing products that might be used. So magnesium chlorides is pretty common, and then calcium chloride, potassium chloride, and then there's non-chloride based de-icers, and many of those are acetate based. This picture here that you see, this is a section of state road outside of Saranac Lake. It has this green salt. We often get questions about why there's that color to the salt, and that's this is magic salt, or there's other names for it, but it's a sodium chloride treated with magnesium chloride, and the color is added so the applicator can better see it on the road. But in this case, we're seeing unfortunately a great example of over application of salt to a road surface. This is much more material being applied than what is needed to maintain this road in safe condition. And obviously that has environmental impacts that we'll talk about, but it's also dollars out of all of our taxpayer pockets that is being just run off the side of this road. So we didn't always use salt to maintain our roads in the winter time. It was actually first used in 1938 in New Hampshire as an experiment, and then began to be broadly adopted in the early 40s. And so this figure here shows the use of road salt in millions of tons nationally in the United States from 1940 through 2016. And so you can see here this sort of exponential rise from the 40s to the 70s as it was being adopted across the United States. And then we plateaued for about 2 decades from about early 70s to early 90s. And then we saw a jump in the 90s up to the levels of application we're seeing today, which is upwards of 25 million tons of salt applied to roads in the United States each year. The story in the Adirondack Park is very similar. In the Adirondacks, we use just shy of 200,000 tons of salt per year. A little more than half of that goes on state roads, and a little less than half of that is applied to local roads. The state roads on this map are highlighted in red. The local roads are in black and the gray shades. And you can see that there's much less state road than there is local road. And because the state's putting more salt on less roadway, that means they put about 3.5 times the amount of salt per mile of road as compared to our local roads. And that's in part due to the fact that state roads tend to be high speed roads and higher traffic roads between communities. And so that you would naturally expect some additional material being needed to apply there to keep them safe. What is concerning, though, is that salt that's applied every year runs off of that road network and into 77% of the lake by surface area in the Adirondack Park and 52% of the stream length. And so just by doing this basic analysis, we can see that there's a potential for widespread contamination of our surface waters in the Adirondacks as a result of the application of salt to our roads. The other point I like to make on this slide and with people as they think about, especially for those that are tuning in from the Adirondacks or have a connection here, we apply almost 200,000 tons of salt to our roads each year in the Adirondack Park, but that doesn't include what's going down on parking lots, sidewalks, private roads, and being put down by contractors. And so we have a little over 100,000 permanent residents in the park. And so you can imagine that if instead of putting the salt down on our roads, we all had it just delivered to the end of our driveway, we would each have, for every household, we would have several tons of salt dumped at the end of our driveway at the beginning of every winter. And I think if that's the way we were seeing this happen, many of us would probably have a different perception of what is going on than having it spread across this road network throughout the entire winter. So we have the potential for surface water salinization, and Dan and Corey from the Watershed Institute here have done some great work looking at that across the Adirondacks and have published that. And we do in fact find that there is regional salinization of our surface waters. And there tends to be, there is this relationship that the greater the density of state roads in a lake's watershed, the higher the concentrations of sodium and chloride. But I wanted to share just a few examples of specific lakes that help tell this story as well. So this is long-term data from Lake Champlain. There's 14 long-term monitoring stations set up in the lake itself. And this is analysis of the chloride concentrations at those stations from 1992 to 2007. The boxes in red show significant increases in the chloride concentration. So there's 9 of those showing a significant increase in chloride. The boxes in green, the 2 of those show significant declines, although you'll notice that the magnitude of the decline is, even though statistically significant over time, is much smaller than the magnitude of increase that we see in many of the other locations. And then these 3 in white show no significant change over time. So even this very large water body, we're seeing this signal from road salt show up in Lake Champlain. If we move away from the lake and into the tributaries, there's 8 tributaries on the New York side of the basin. All 8 show significant increases in chloride concentration over this period. And there's 10 on the Vermont side, and it's half of them that show a significant increase. Lake George is another water body that we often hear about when we're discussing road salt pollution. There's been some great work done down there by the Darren Freshwater Institute and the Fund for Lake George and the Jefferson Project to both study and address the issue in the Lake George watershed. These are data of both sodium and chloride concentrations in Lake George from 1980 through 2010. And again, we see a significant increase in both of them over that period of time. And then we have Mirror Lake that we're going to be talking about in more detail in just a few minutes. But again, in Mirror Lake, we have less data. It's more scattershot. The monitoring there hasn't been as consistent as some of these other larger, more well-known water bodies. But the data that we do have goes back all the way to 1974 through today. And again, for both chloride and sodium, we see a significant increase in the concentrations over that period of time. And we could sit here for another hour going lake by lake around the region, telling the same story over and over again. We also have some stream data that we've collected, or the Al Sable River Association has collected, looking at streams throughout the year. And in that data, we saw a signal of what could have been an indication of groundwater contamination, where we see persistently high chloride concentrations in the late summer, early fall months when our streams are at base flow and are fed primarily by groundwater. Again, Dan and the team here at AWI looked into this in great detail over the last several years, sampling over 500 private wells across the park, and they indeed found regional groundwater salinization as well. So the salt isn't just in our surface waters, it's in our groundwaters as well. And this is of no surprise for those of us that are studying this, because about half of the runoff off of a road ends up going into the groundwater. The other half will make it overland into a stream or a lake. These are some of the results from the groundwater work that Dan has been doing for the past few years. And so each one of these dots is a well that exceeds the sodium guidance value set by the EPA for drinking water quality. And that's 20 parts per million, and parts per million and milligrams per liter are interchangeable. So when you see those represented throughout the presentation, you can interchange those units. And so we see downslope of local roads, 20% of the wells exceed this guidance value, but downslope of state roads, it's 64%. And again, this reflects the higher application rate of salt that's applied on state roads as compared to local roads. We see a similar story for chloride, but the threshold is higher. The sodium threshold's mostly to protect human health, and especially those that have high risk of kidney disease, heart disease, and other things that your doctor might put you on a restricted sodium diet for. Whereas the chloride threshold is mostly a taste issue at this point. And so the threshold is higher, and as a result of that, we see fewer wells exceeding that threshold, but we see the same pattern where a larger proportion of wells are exceeding that threshold downslope of state roads as compared to local roads. A story that I don't think gets told often enough, or a connection that isn't made frequently enough, is many people know of the Flint, Michigan water crisis and the lead pollution and poisoning that was happening there. The connection that doesn't always get made about that is why it happened. And a big part of that story is they switched their water supply from relatively clean water to more polluted water of the Flint River that had a whole bunch of stuff in it, one of those things being road salt. And the increased salinity of that water and corrosivity of the water meant that there was a greater chance that heavy metals such as lead would be leached out of the water system that it was running through. And they could have taken action proactively to limit that, but they failed to do that. But a big part of it was the fact that they were using this water that wasn't as clean as their prior source of water. And this can happen in private homes and wells as well. If there are fixtures in a home that are made of these metals that are a concern for human health, and your water is contaminated and saltier than it should be, you could see increased leaching of these heavy metals out of those fixtures. The folks that really uncovered the Flint, Michigan water crisis sort of coincidentally have also published a paper based out of Orleans, New York, and St. Lawrence County, looking at groundwater contamination from road salt storage sheds, but also road application. And they found the same trends that we just presented, that Dan has found here in the Adirondacks. So it's nice to see that our data is pairing up nicely with another researcher and just outside of our region. And then we also see they modeled that across all of New York State, and there's the potential for 460,000 well users in New York State to be drinking water that's affected by road salt. And on top of that, they've done bench scale testing to show that leaching of heavy metals out of these fixtures at these higher chloride concentrations. So this is not just an environmental issue, but it's a human health issue and potentially an economic issue too, in terms of home values and your tax base when you look at assessed values of homes. So we'll get into now dive into the story of Mirror Lake in the village of Lake Placid. As a quick orientation for folks, if you're not familiar with Mirror Lake, we are in the Adirondack Park, but we're within there in the Lake Champlain Basin, on the New York side of the basin in the Au River watershed, at the headwaters of the watershed in the village of Lake Placid. It's a small water body in the headwaters of the west branch of the Au River. It's not a particularly large water body, and I'm sorry that there's a big black blob here on the screen. I don't know why that's displaying that way, but it's 50 hectares in size. The surface area, 301 hectare watershed. Its maximum depth is 18 meters or 60 feet. And if you look at this map of the lake bottom here, you can see that it's a really simple basin morphometry. There's one main deep basin in the middle of the lake, and there is another little sub-basin on the southern end. Water flows off of the headwaters of the watershed at Cobble Hill and Mount Whitney into the north end of the lake, and then it flows out the south end into the Chubb River, which then goes into the west branch of the Au Sable. The unique thing about Mirror Lake is that 27% of the watershed area is developed. And when I say watershed area, that includes the surface area of the lake, because that's part of the watershed for Mirror Lake. Any water that falls on the surface of Mirror Lake is going to obviously end up in Mirror Lake. If we look at just the land within the Mirror Lake watershed, it's 34% of the land is developed. And this image captures almost the entire watershed. So the headwaters are up here on this is Mount Whitney, and Cobble Hill is just off the screen. And the watershed divide comes down Mount Whitney between Mirror Lake and Lake Placid, and then up the hill above Main Street, Lake Placid, capturing all of Main Street and downtown Lake Placid, and then over through the big municipal lot by the conference center, and then down to the outlet, which is right here. And then it sort of does the same path on the other side of the lake up to Cobble Hill. And so you can see in this photo that not only do we have a lot of development, but the development is concentrated right against the shore of the lake, particularly the western shore. But there are homes ringing the entire lake, and there's only a little bit of undeveloped shoreline on sort of the east side. And this amount of development firmly lands Mirror Lake into the classification of an urban lake. And it's really an outlier within the Adirondack Park in terms of the amount of development that exists within its watershed. And then, of course, with that development comes parking lots, sidewalks, roads, entryways, all of those things that need to be maintained free of snow and ice in the wintertime. And one of the primary ways those surfaces are kept free of snow and ice is the application of salt. So this is looking in downtown Lake Placid, and you can see these big streaks of salt on both sides of the road from a recent application, and this is early in the winter. And when the salt does its job on those surfaces and it melts snow and ice, it runs into a stormwater system that discharges directly to the lake. And so there's 14 of these pipes now that are around the lake that run straight off the street into the lake. And we've sampled these on a number of different occasions, and it's not uncommon in the middle of winter to get a chloride concentration in this water of 2,400 milligrams per liter. And for many of you, that might not mean much. So here are a few references to scale that against. That is 10,000 times higher than what we would expect to find in an Adirondack stream or lake. It is about 10 times higher than the chronic toxicity threshold for aquatic life set by the EPA. And so that's half of the organisms die if exposed to that concentration for 4 days. And it's about 3 times higher than the acute toxicity threshold, which is half of the organisms die if exposed for 4 hours. So this is a lot of salt coming out of these stormwater pipes at really high concentrations. What is interesting is what happens after it enters the lake. So we have all these pipes around the lake, and if we If we look at the lake in a cross section, those pipes are pouring in on the side of the lake, and that water, because of all the additional salt in it, is denser than the water that's in Mirror Lake. And so it flows right along the lake bottom. And throughout the winter, it builds up and accumulates from the bottom up. And so by the end of winter, we have high chloride concentrations down in the bottom half of the lake, lower concentrations at the top. We also have low dissolved oxygen at this point because this water has been trapped down there all winter long. And so if you're one of the lake trout that are in Mirror Lake, which is our native cold water salmonid, lake dwelling salmonid here in the Adirondacks, they are not going to be venturing into this part of the lake in the winter time because of the low oxygen and potentially the high chloride concentration. So when the ice goes out, we would normally expect Mirror Lake to go through a process of spring turnover, and it does, but what happens is only the upper half of the lake mixes because this water down here is too dense and to mix up to the surface. And so the top of the lake mixes, but the bottom of the lake doesn't completely mix. And so we keep this high chloride and low dissolved oxygen situation where normally we would see this water at the bottom get mixed up to the surface, absorb oxygen from interfacing with the atmosphere, and we'd have the whole water column well oxygenated at the end of spring. And then we go into early summer and we start to warm the surface of the lake and it starts to thermally stratify. And so now the lake trout in the lake are trying to find this Goldilocks zone where it's both cool enough and well oxygenated enough. So they're not going deep because there's no oxygen down there, and they're not up near the surface because it's too warm. And as we advance through summer, we start to squeeze them into a narrower and narrower band of water to the point that in some years, by the time we get to the late summer, there is no preferable habitat left in the water column. And it's important to note, I said preferable, because that means that the fish are likely under some level of physiological stress, and the juveniles would be under greater stress than adults. It doesn't mean that the fish are going to die from these conditions, but it means they're probably going to be maybe less healthy, less likely to reproduce, and those sorts of things. So that animation is driven by a whole lot of data that we've been collecting on the lake since May 2015. And a lot of this was done while I was at the Ausable River Association, so credit to them for supporting the work for all these years, and was done in partnership with here at AWI. But this figure here, for those of you that are interested in the data behind the story, represents all of that work over the last 5 or 6 years. So the way you read this is the top of the figure is the top of the lake, the bottom of the figure is the bottom of the lake, and we have time from May 2015 through last week, going left to right. The colors that you see correspond to the concentration of salt or chloride at that particular depth and time. The pattern we see is in around the winter time, so just around the beginning of the year, we see at the bottom chlorides start to build up at the bottom of the lake, and that's that runoff coming out of the stormwater system and settling down to the lake bottom. It wasn't too bad in 2016, but it was quite noticeable in 2017, 18, 19. 2020 was a bit of a better year. If we look during the periods of spring and fall turnover, which are going to be sort of early in the year and late in the year, if you see the same color top to bottom, that is one way that we know the lake potentially mixed completely. So we see that occurred in the fall of 2015. It occurred in the spring of 2016 and the fall of 2016, exactly what we would expect a lake here in the Adirondacks of this depth and size to do. But in 2017, we see that the concentrations of chloride remain high at the bottom of the lake, around 70 to 80 milligrams per liter, while up at the surface, they're around 30 to 40. So we had incomplete mixing in this spring. And in the fall, though, the lake mixes completely. So we see we're at about 50 top to bottom. And then that pattern repeats for the next 3 years. 2018, it doesn't mix in the spring, but it mixes in the fall, does that again in 2019. But in 2020, it mixed in the spring, and we have these uniform concentrations from top to bottom. So the consequence of the lack of mixing, there's a bunch of biological, chemical, and physical consequences, but one of them that's particularly of particular interest is what that means for oxygen. As I described in the animation, this is the same type of figure, but now we're looking at dissolved oxygen instead of chloride. So red areas have low or no oxygen, blue areas have lots of oxygen. If we look at the spring where it mixed in 2016, we see high concentrations of oxygen from top to bottom. And as we go into that summer stratified period, we see the oxygen decline at the lake bottom, and that's normal and expected for Mirror Lake. And then in the fall, we see the oxygen come up again at the bottom as the lake mixes. But then in those years where the lake is not mixing in the spring, we see low oxygen occurring at the bottom of the lake for a longer period of time, almost the entire year, and a greater spatial extent in the water column. So higher up in the water column earlier in the year. And that pattern again repeats in 2017, 18, and 19 when the lake did not mix in the spring. And in 2020, this year, the lake did mix. So we see those oxygen concentrations high top to bottom in the spring, and now they're in the process of declining. So the low oxygen at the lake bottom has a cascade of effects on the lake. One of them that if you tuned into Kurt Stager's talk, he talked about these prolonged periods of lack of mixing as a result of climate change. And here it's happening because of road salt. And a result of that is the long period of low oxygen at the lake bottom means that we get more phosphorus leaching out of the sediments at the bottom of the lake, and we call this internal phosphorus loading. Phosphorus is the primary limiting nutrient in aquatic ecosystems, so that means the lake is more vulnerable to something like an algal bloom. And we've done some preliminary modeling on what would happen to the lake if it stopped mixing in the fall as well. And depending on the duration of ice cover after that, so if it was a long winter with a long period of ice cover, there is a chance that we would see a winter fish kill occur in the lake. And so without that reoxygenation in the fall, the oxygen would continue to decline underneath the ice, and it could get to the point where we would see fish die off in the lake occurring. So obviously both of these things are outcomes that we do not want to see for Mirror Lake, and thankfully so far there are things that we have not observed in the lake, but this lack of mixing makes the lake more vulnerable to them. If you want to read more about it, we do have a paper out in the peer-reviewed journal Lake and Reservoir Management. We can share that with anyone that's interested in reading the science behind this, if that's something that you're curious to read. But Mirror Lake mixed in 2016 and 2020, and the big question is why? And that we addressed that to some extent in the paper that I just shared, but obviously we didn't have the 2020 data at that point in time. And so this is something that we're really interested in, is figuring out exactly why it mixes in some years, but not others. And the first thing that we look at is the snowfall. So some gauge of how severe the winter is, because obviously if it's a more severe winter, we're going to put more salt down, more salt's going to accumulate in the lake. That's going to increase that density difference, and the lake is less likely to turn over. And so this is snowfall data for Lake Placid. The bars represent the observed snowfall in every month from the beginning of the 2015-16 winter through this past winter. And the black dots represent the 1981 to 2010 climate normal. And what we see is that 2016 was below normal year, 2017 was quite a bit above normal, 2018 was sort of normal, 2019 again above normal, and 2020 above normal to an extent. Down at the bottom, I've just showed for the annual total what the the normal snowfall is in centimeters for Lake Placid, and then what we observe. So again, 2016, about 60% of normal, and 2017 we're quite a bit above, 2018 pretty close, 2019 quite a bit above again, and 2020 above. I've also put in the ice out date. So the spring of 2016 was one of the earliest ice out dates on record, which extends back to the early 1900s, March 27th, sorry. And then in 2017, we're several weeks later, April 16th, and then 2018, even later, May 4th, 2019, May 22nd, and then this past winter was, again, quite early for Mirror Lake in April 6th. So initially, when we published our initial paper on this, we were looking at 2016 as the year of to demonstrate how to get Mirror Lake to mix with all the salt going in it. And it appeared to be low snowfall means less salt applied. Combine that with early ice out, and you get the lake to mix. But then 2020 presents sort of a different scenario. So if we look at this a different way, again, this is a similar plot. We have snowfall, but in this time, instead of plotting the climate normal, I've plotted the total amount of chloride that is retained in Mirror Lake. And so we see every winter as we apply, we have winter set in and we start applying salt to the watershed, the chloride in the lake goes up. In the spring, it goes down. Some summers, it goes up a little bit, and we can maybe address that in the Q&A if folks have questions about that. Again, in the winter, it goes up, down, up, down, up, down. But 2020, we didn't see much salt accumulating in the lake, even though we had this above normal snowfall. And so this really begs the question of what is the thing that's causing, that caused the lake to turn over this year. So there's sort of three factors that come into play. The weather, if we have a more severe winter, everything else being equal, we would expect more salt to be applied. If we have an early ice out, that prolongs the opportunity for the lake to mix. And then we have the management actions of those that are applying salt in the watershed. And the hopeful piece of, the hopeful interpretation of these data, which is still just an interpretation and not any sort of conclusion, is that 2020, we saw an improvement in salt application within the watershed that meant that the town, the village, the state, and the private applicators that we've been working with for the last few years were able to put less salt down, even though they had a slightly above normal snowfall. And if that combined with an early ice out allowed the lake to mix. And if that is the case, that is great news for our efforts to address road salt pollution, because it means that we're making some ground in terms of salt application to the watershed. But this all is still a bit of speculation. And so it really requires us to have a strategic approach to how we address this problem. And we've been working on a project that was funded through the Ausable River Association with a grant awarded to them by the Lake Champlain Basin Program to do just that. And the fundamental question is, how much do we need to reduce our salt application in order to get Mirror Lake to mix? And that requires a really critical piece of information that we haven't had up until this coming winter season, and that is knowing the amount of salt that's being applied to the watershed. We've been looking here in the lake and guessing what's going on with salt application rates, but we really need to know those application rates to know whether or not the reason we had less salt accumulate in the lake this past winter was because of a reduction in application, and where did that reduction occur? Who was it that put less salt down, and how do we learn about their success and then apply it to other applicators? We also need to be able to track that salt through the environment better, through the stormwater system, groundwater, and then exporting out to the Chub River. The challenge with the Mirror Lake watershed is there's so many different applicators applying salt within the watershed. All of these different colors represent different types of surfaces within the watershed that may be receiving salt. And we've added these up, and into total area and then further broken them down by whether it's the town, village, or state maintaining them. And we see there's more parking lot in the Mirror Lake watershed than there is any single road type. So there's more parking lot than village road than there is town or state road. We also see that there's as much village sidewalk as there is state road, and sidewalks on average tend to receive higher application rates of salt than roads do. So this winter, we will have 3 village vehicles and 1 town vehicle, which are all the municipal vehicles operating in the Mirror Lake watershed, outfitted with AVL equipment. And we had 1 truck running last year, sort of a pilot to get the project going. And this is a GPS track of that truck's route. The colors don't relate to the salt application. They're related to speed, but you can see they come out of the village highway garage and head out into the village and are making passes down all of these streets and around Mirror Lake. And while we're also measuring the location of the truck every 20 seconds, we're also measuring the amount of material coming out of the back of it. So we'll have that for the state, the town, and the village for this coming winter. We've also put in cameras looking at the surface of the road so that the highway department supervisors can do a play-by-play after the fact. If they try a different technology or a different application rate, they can go back and see how their roads behaved after that treatment was applied. We're also sampling the stormwater system consistently over the next 2 winters. So we've done this sort of sporadically in the past, but we've never had funding to do it systematically. We will be doing that the next 2 winters. And we also have some technology in 2 of the stormwater outfalls that allow us to continuously monitor the amount of salt coming out of them every 10 minutes all year long. We're coupling that with sort of backing out to the larger Chub River watershed to track the movement of salt throughout the entire village of Lake Placid. We have 5 continuous monitoring stations installed in the watershed, and these are placed so that we can track what's going in and out of Mirror Lake, so the inlet and outlet. We can track what's coming out of the whole Chub River watershed, and then we have these 2 stations up in the headwaters of the watershed that allow us to essentially isolate the village, which is where all this red is in the middle of the watershed. And then we continue the monitoring on Mirror Lake, and Mirror Lake's unique in that it's one of few lakes in the state and even the country that have monitoring occurring all year long. But winter is the most important time for monitoring on Mirror Lake, so that's when all the salt is going into it. And then this summer, we just installed in partnership with the Ausable River Association and Kevin Rose at RPI, a permanent buoy in the lake that has data loggers hung below it that will allow us to see what's going on in the lake every 10 minutes, again, all year long at every depth in the water column. And our intent is to let this freeze into the ice, and we'll all have our fingers crossed all winter long that it's still there when ice goes out in the spring. And then the Ausable River Association this past summer purchased 2 new plows for the town and the village that conform to the shape of the road surface, allowing them to more effectively remove snow and ice in front of the truck, meaning less material has to go out the back. And the town has already had one of these. They bought one on their own a few years ago, and this is the boundary between the town and village road on one particular day. It isn't always this obvious, but these plows, these live edge plows, can really scrape some of this hard pack off the road surface much better. And you can see that difference where this is where the live edge plow runs, and this is where just a regular straight bladed plows run. And then another unique component of this is we're measuring sidewalk application as well. In these urban environments, it's much more than what's going on the road surface. Sidewalks, parking lots, driveways, all can add up to quite a bit of salt. And so I think we might be one of the first places in New York, I don't know, maybe even the country, that is going to have AVL equipment on a sidewalk sweeper. So we can see where these sweepers are going, and again, how much material is coming out of the back of them. So that project will really be getting off the ground this winter, and it is designed to give us the data to really understand why the lake when the lake mixes, why, and then give us the information so we can be very strategic about the management options available to us to reduce the amount of salt applied to the watershed so that we have an effective outcome for the lake. That's largely funded by the Lake Champlain Basin Program, but this work is supported by a whole bunch of different entities in and around the village of Lake Placid, and kudos and thanks to all of them for the support for the last several years. And with that, if there are any questions that Dan has queued up for me, I'm more than happy to answer them.
Yeah, great. Get my video started. Excellent, Brendan. Thank you very much. Yes, as you can imagine, we have a nice variety of questions for you. And I'll take the first one here. I would think that the findings in Mirror Lake will be slightly higher than the other small lakes in the region because it's highly populated in a small lake.
Yeah, absolutely. So like I said, Mirror Lake really is an outlier in the Adirondacks in terms of the amount of development that's around it, and then the fact that that development is concentrated right around the lake itself. And it's a small water body. All of those things combined are the reason why we're seeing this phenomenon happen in Mirror Lake. And in fact, there are only 9 lakes in the published scientific literature that have this interruption and turnover. There's probably many more out there that just haven't been studied, but it's a distinction that I'm sure all of us that care about waters in the Adirondacks would like not to have.
Great. Question, do you obtain total tonnage of salt that local and state road departments use in any given year? This would help determine an amount of available salt that could be introduced into Mirror Lake.
So Dan, you might be able to weigh on this a little bit, but he has done that.
Yeah.
And that's how we know the park-wide application rates, and we can break that down into municipality. The problem with that is you make the assumption that what's purchased every year is used, which is probably not a bad assumption. But then you have to make the assumption that what is purchased every year is evenly applied to all of the surfaces that that village or town maintains. And that might not be as good of an assumption. And from the AVL data we have just from one season on one truck, we can see the application rate varies quite a bit across the watershed. So having that really fine-grained detailed data from the back of the truck is going to give us a much better estimate. But we have done sort of the back of the envelope calculations based on just knowing purchase records.
Yeah, we just agree with that. So the numbers that Brendan presented was 108,000 tons, tons. That was from, so the New York State Office of General Services is where all this stuff is purchased through. And I was able to download all the purchase records, and so we just totaled those up. But those are the purchases, and we assume that 12 years of purchase average of that would be an annual application rate, but that's a steady state across the road network, and we know that that's not how it's done. So the way that Brandon has got it formulated with the real-time tracking and actual rates is really going to get at this particular question of actually what gets put down and when. I am curious about fleet deterioration within the DOT due to road salt applications. So effects on their equipment.
Yeah, I'm curious the effect on my truck. I know I've spent some money repairing it because of the salt application on our roads. I know a DOT does look at that. They're aware of it. I mean, you will notice some of the newer trucks actually have aluminum beds on them, which is partly because they're more resistant to corrosion than the steel frames that they would have had in the past. And I think all of the local highway departments will talk to you the same thing about equipment replacement costs. And some of them have even started putting in their own wash bays so that they can clean their trucks more frequently to give them a longer service life. So we all pay for it in our own vehicle repairs, and then the tax dollars to replace that expensive equipment.
Great, thanks. question on what are the acute points of opposition in the application changing? So who's opposed, I guess, to changing the status quo?
I honestly, and I don't know, maybe Dan, you can weigh in, but I don't run into many people that are opposed to changing what we're doing. Where it becomes challenging is there's no silver bullet. It really is about a weight of approaches to bring that application down. And the other thing is we have the very real concern about public safety that we have to keep in mind as well. So in the past, we've sort of ignored the environmental impact and some of the human health impact that are indirect through groundwater contamination. And we've just weighted public safety, which is why we've ended up in the situation we're at. We need to balance those things. We need to find a better balance. And I think that's what everyone that's working on this issue is trying to achieve.
Yeah, I think it's well said. The only thing I would add is you know, so local municipalities like the ones that Brennan is working with, and also the folks, the ones down Lake George, have been very cooperative and amenable and interested in thinking differently and trying these different methods to reduce salt use while also maintaining a safe driving surface. The state highway system, they're a little bit less, they're a little bit more recalcitrant, and you know, they're really, what they talk about is often talk about liability and you know, being liable for someone gets in an accident because the road's not properly cleared. So they often talk about that, and also certainly they talk about safety and their requirement to maintain the roads at a certain level of service. So there's this difference. There's a pretty marked distinction between when you're talking about local government and what they're willing to do versus the state government or the state agency rather, and what they're willing to do. And I think that speaks to, I was going to look, there's a question on here about the Randy Preston Road Salt Reduction Act, Brendan. So will we be speaking to the Randy Preston Road Salt Reduction Act that passed the state senate? If you want to, that relates to the state situation. Do you want to take a crack at that, or?
Yeah, I think it's that hopefully the governor signs it. It's forming a task force to help better guide the DOT to a more sustainable solution. So it's the first step. And it's also the fact that it's gotten this far, though, I think is a testament to this is a real concern for New York State, not just the Adirondacks. And we need folks to start taking it a bit more seriously. And some of these impacts can be mitigated and resolved pretty quickly in some of the surface water bodies, but the groundwater piece is really a long-term impact that we're going to be dealing with for a long time. So the sooner we start moving in a better direction on that, the sooner our groundwater resources can begin to recover.
Yeah, well said. I would just say that, Brendan and I have been working with a group of just really a grassroots effort for a number of years, sharing the science that Brendan presented and other science with elected officials, with the agency people, and we've been able to working together, and also with Randy Preston Bill, because he was the supervisor for the town of Wilmington for a long time, and was the real champion for us doing stuff differently. And so that's why the bill's named after him. But we're really thrilled, I think, to be able to have a task force, which will be it won't be a DOT task force. It will be the governor's task force with representation from across the agencies, including not only agencies, but scientists like ourselves and others, to be able to have a real conversation about winter road management and balancing the needs of safe roads with the needs of safe drinking water and the needs of a healthy environment. So we're happy with that. We're excited. Question about other techniques. So does the Adirondacks use sand as snow removal technique?
Yeah, so the local municipalities, for the most part, on most of their roads, use some sand salt mixture. The actual proportions vary by municipality. Um, and that is a good alternative. The concern with sand, though, is it also has impacts on lakes and rivers in terms of sedimentation. So Wilmington was actually a great example. Randy was so passionate about this, and he understood the issue well enough, and so did Bill Skufka, their highway department supervisor, that they would be out cleaning the streets before the last snowfall had even happened. And that is an important consideration with sand, is that we manage it and pick it up or capture it in an appropriate way so that it doesn't run off into our rivers and affect spawning areas for trout and habitat for bugs. And so it is a good option. And some of the local towns have asked the state to be able to sand the state roads through their towns that are lower speed, and to make the driving experience in their communities more consistent. You don't go from this salted state road to a sanded town road at an intersection and have to navigate that difference. So it is being discussed. I'm sure the task force would be looking at how do we implement that. And the state has experimented with it a little bit on the Route 86 pilot that they have going from Lake Placid to Wilmington. So it is being looked into.
So really kind of a suite of questions related to alternative treatments. So one is just a general question, what can be used instead of salt? You just talked about sand. And then there's just two related to brining. So if you could address those.
Yeah, so brine can be an effective way to reduce your salt use. So you basically, it's salt still, but it's just you dissolve it in water at a very specific concentration. You put it down in liquid form. It's great for pre-treating a road. So you put it down before the storm and you get a thin coat of salt, and that prevents the bond of snow and ice to the surface. We all know that if you're being a little lazy in the morning, or you're late to work and you just walk across your driveway or your walkway, and then you drive across and you come back at the end of the day and you try and shovel, it's easy to get the snow off everywhere except for where we had footsteps and where your car tires went. And that's because the compaction bonded that snow to the surface of your driveway. So brining a road in advance will prevent that bond from happening. And that's really the goal of using salt, is to prevent that bond and not to be melting everything away. That's what the plow should be doing, is physically removing it. The challenge with brining is it's not just as simple as dissolving a bag of salt in some water and spraying it on a surface. The concentration needs to be tailored to the temperature and humidity and the pavement temperature. Otherwise, you can get flash refreezing on roads. And we've seen that with some test applications in Lake Placid. And so municipalities that are going to adopt that, or private businesses, need to have some training and support in order to make sure they do it effectively. But it is a great option to bring our salt applications down.
Great, thank you. We got to get COVID in here. So here's a
Oh no.
How do you think COVID impacted the water? Does lower traffic make a difference?
That's a great question. I'm not sure. In our area up here, I feel like, that really hit at the end of the winter season. And so we don't have a year that we would really be able to evaluate that for. And in the Adirondacks, it's been busier than normal once the state reopened. So I'm not sure we're seeing lower traffic in our communities right now. But the other, I guess the extreme side of that is traffic. It can also be beneficial to help work the salt into the snow and ice. And so if you have a very low traffic road, you might actually need to apply more salt than if you had a surface that was continually being worked by tires, and that can be beneficial. So that's a tough question.
Here's a couple of questions related to trying to manage the dense layer that forms. So the first question is a long one. A similar problem with a dense salt water layer occurs in a pond in Maine from entrance of seawater following a dam breach, which has been minimized by installing a siphon system remove the denser water. And any thoughts on a similar method to aid Mirror Lake?
Yeah, so we could do that, and siphon systems aren't too expensive in the grand scheme of things, but we would ruin the lake trout habitat in the process because we'd be sucking all the cold water out of the bottom of the lake. And so we would anticipate that as a result of that, the lake would become unstratified, or mostly unstratified. It would be warm top to bottom because instead of the water flowing in at the surface and staying warm and flowing out the surface, it would be flowing in the surface and then going down to the bottom of the lake and coming out. And so we'd end up with an entirely warm water body. And I'm not sure that would be an outcome that we would want for Mirror Lake.
Another question related to managing the mixing is, have you considered mechanical means to mix the lake?
Yeah, and again, so mechanical mixing is another option. But if we want to keep the lake thermally stratified in the summer, we'd be looking at a system capable of mixing Mirror Lake in the time frame of a couple days to mimic the natural mixing process. So again, and these systems that's more expensive. There's also aeration systems that are quite expensive. We think that it's much cheaper and more sustainable in the long run just to address the problem at the source and let Mirror Lake recover back to its normal mixing regime. And we think that's entirely possible. And so we're not, at this point, suggesting any significant investment like a mechanical mixing or siphoning or aeration.
So I'm going to do two more questions, and actually there's just two left. So, this one is from a person who actually participated in the well study. And so they said there was a large amount of salt found in their water. They're asking what can be done about limiting the amount of salt on a town road. They're saying, we've contacted the highway department supervisor asking if they can reduce salt application near our well because it's close to the road, and they refused. Every year for the past 5 to 6 years, we cannot drink our water from March to June due to a high salt level and poor taste.
So the first thing I think is to encourage your highway department. There's a lot of training opportunities being offered by organizations like the Ausable River Association, 80K Action, the Fund for Lake George, the Lake Champlain Sea Grant, AWI. We're all trying to provide resources to highway departments to give them the professional development to learn from places like Lake George and other parts of the country. So, I would encourage your highway department to take advantage of those opportunities is the first thing. That opens up the conversation, and they're talking to folks within their profession that they can relate to more than us citizens or, scientists, or even worse to be talking to highway department folks a lot of times.
Yeah.
And so, that's a great resource. And then Dan, I don't know if you have any specific recommendations in terms of like an individual well and how to manage that.
No, I think you hit it. The only other option, of course, for them would be to actually install a reverse osmosis system or that kind of thing, which is so similar to the mixing. It's better not to have the problem, but if you need to utilize the water, your only real option would be to invest. It's very expensive. Invest in a treatment system for your water, a whole house treatment system for you, because you're probably having some serious problems with your plumbing and your dishwasher and your hot water heater. So, but I think Brendan's recommendation is the first one to try. But again, while that's being tried, you might invest in a water treatment system for yourself. And if you receive the report, so in the report that you received, there was a guidance to contact the Department of Health to get more information from them on water treatment options for you. So if you don't have that anymore, you can send me an email, dkelting@pulsemist.edu, and I can resend you that information. One more, let me see, one more question. So this is a good one. So thinking about really other parts of the world, and we're not the only places that get snow. So a question about the Alps. Do the Alps have a better idea, or have you looked in Europe or other places to see what they do?
Yeah, and even the mayor of Lake Placid, when his travels for bringing winter sports to Lake Placid, has observed what's going on in European countries and thought about how could we learn from their techniques. So a lot of European countries use more, they focus more on letting the hard pack form and then keeping traction on that hard pack. So that means putting down like pea-sized gravel and that sort of thing to get embedded into the snow so your tires still can grip. Out west, they have sort of a wider range of service that they provide on their roads. And so they, main highways are going to be kept clear, but, mountain pass roads that aren't traveled very often might have limited maintenance, and you might have chains required in order to go up and over those passes. So the challenge with all of those things is it would take the driving public's support for that to happen, because all of them are going to mean, either you need to take a longer period of time to get from point A to point B. With the gravel stuff, you can get chipped windshields getting kicked up and that sort of thing. So, and that is a big part that a lot of us have been talking about and trying to get our heads around, is how do we get the driving public to accept a slightly different level of service on their roads, because that is one of the major things that's driven that national trend towards more salt use. As the highway departments make our roads better in the winter by putting more salt down, the public expects the road to be that way or a little bit better, and it keeps pushing it, towards more and more salt use. So they're all being looked at, and again, unfortunately, there's no silver bullet.
So let's thank Brendan for an excellent presentation and a great job at answering your questions, and thanks for your questions. So you can do a hand wave or just virtually thank them in silence. So